So I'm going to show you how the Python SDK works. But before I do that, I want to show you where you can actually find it. So we have a Python SDK package. This you can install directly from PyP as a normal Python package. Then also we have given you some examples of how to use the Python SDK. These are examples on how to use the package to check the battery, check the impedance, record data, download all the normal things we want to do with the device. So let's assume we have now installed the package. We have now also downloaded the examples from GitHub. So what would we usually do in the start? We can check the battery. So you can see with the examples, we will have a file called check battery. So what it does, it just accesses the package and checks the battery. So I will run that file by saying Python check battery. You will see it will connect to all the devices or see all the devices in the office, but we know that this is our device, so I'll connect to that. So the battery level is currently 30. You could see the lights were flashing dark when it connected and disconnected. Next thing that we might do is check the impedance. So this will show how well is the device actually connected. So I'll say Python check impedance just to show you how the file looks. It's very simple code. You can change how long you want to check the impedance for. Also, if you might be in the USA, you want to add a filter at 60 Hz. So you can say true if you're on USA, otherwise in Europe you can just keep it to the default settings. So if I say Python check impedance, it will also first look for all the devices in the office, and then we'll also choose again, our device is F6, so yeah, we choose that. You'll see then it's subscribing, and you can see it's blue. It's currently being streamed to the cloud. So as you can see, it's a very high impedance because nothing is touching it. Once I actually hold it, you'll see it goes much lower. Because it's not flatlining anymore. So currently it is for 50 seconds. I'm going to stop it. How do I stop it? By pressing Ctrl C. That sends a stop command to the terminal, and it gracefully stops it. What do I mean with gracefully? Is we have time to send a stop signal to the cloud, and we also have a time to disconnect to the device. And this is normal. This is just because of the cancellation script. So what is next? So we've now checked the battery, we've checked the impedance. Now we can maybe go to an actual recording. So if I say so Python recorded LSL, so you can also do normal recording. This will just record your data, send it to the cloud, and then you can download it afterwards. But what I would like to do is record LSL. What does LSL do? It basically streams your data not just to our cloud, but to the local network. This enables you to maybe synchronize your data with other streams of data. It also allows you to capture again from the local network your data already pre-processed and filtered and decrypted. And then you can visualize it or create a classifier or develop whatever you want. But yeah, it enables a lot of things like that. So what I'll say is Python record LSL, which is now running this file. So again, it's connecting, it sees all the devices. I am now device number 1. You see it's subscribing, it's connected, it's blue. Great. And because I'm running the LSL script, so these are all outputs from the LSL, we know that I can probably capture the code again. So what I'm going to do is I'm going to run a example, visualize EG cloud, and this should, I'll explain in a second what we are visualizing. But basically our data is going encrypted and raw to the cloud, and it will be coming back to us filtered and decrypted. And then the LSL puts it on the local network, which you can then visualize quite nicely. So in a moment you should be seeing some ECG. So it's important if you test like this also to hold the external ground. Just make sure that the signal is in the correct range at least. But you can also put it in the ears. So usually we need some time to stabilize, but we should be able to already see some stings. So if I clench my jaw, you'll see this high frequency. So why is it not that clear? Because we have pre-filtered the data. So you get the data filtered between 1 and 35 Hz, meaning high frequency activity might not be that clear, but these are usually artifacts we want to avoid. If I look left and right, you should see these dips, which are also happening between 0 and 1 Hz, which are also filtered out. Yeah, and then how do I end the recording? There's two ways. The one is to wait until the time ends. You can also determine that time yourself. At the moment it's 5,000 seconds, but you can make 5 seconds, 60 seconds. So this gives you a lot of freedom to create your own protocol. You can also always change these functions, create multiple recordings in parallel or whatever you need to do. But how I will end the recording now is control signal. This might differ depending on your computer, but you can easily find out what is the standard controls, basic standard cancellation command for your computer. So for me it's Control C on the MacBook. What that tells is it tells the cloud that the recording is finished, you can now process it, and the device is also now disconnected. So what can I do now is I can actually go and download the recording. So I could download recording. Here you have the example of what to put in. So from the output you can also go to the log files and find these outputs if you clear your terminal or something like that. But from the output, or let me just take this one, I will go to download data. So I put in my recording ID, then I also put in my device ID, and then I can run that script. So now it's ready with a bit of adjustments. I can say Python download data, and then I need to put in a password. So I obviously not put my correct password in now, but when it's downloaded you'll get the data. So that's currently, you can also check your information on the cloud. You can run Python get info all, so get info on the cloud, and info single, you can get info on a single recording. This will give you things like when was it recorded, is it still processing, etc.